In this video, we're looking at tables of random digits and how they can be used to model the basic ideas of probability and randomness. It also happens to be EHW2 Electronic Homework 2 from my Introductory Stats course at Bethel University. So we're going to go through a homework problem for them, but it's more than just a homework problem. It's trying to help you understand what randomness is all about and how it can be modeled. How is it related to basic probability? As far as my students go, though, you should try to do these things on your own as well as watching what I do. You should mimic what I do after seeing it. So here we have exercise 4.7 in the textbook we use. Could be a different problem in a future textbook. As discussed in a previous chapter, chapter 3, generation of random numbers is one approach to obtaining something called a simple random sample, a real fundamental idea in statistics where we have some big population of individuals. They could be people, they could be companies, lots of different things. And we want to take a random sample from that so that we can use our methods that we're going to talk about in future chapters to understand what's going on with the population. So SRS stands for simple random sample. If we were to look at the random generation of digits, the mechanism, however that is done, should give each digit a probability 0.1. You could also call it 10%. And in this problem, we're going to consider the digit 0 in particular throughout this problem. Okay, but we could consider any of the 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Just a single number that's given with the single symbol. Symbol is called a digit, matching the fact that you have 10 digits on your hands. Okay, so the first part of the problem, part A, is to look at a table of random digits, table B in the textbook. We'll look at that in just a minute here. It was produced by some random mechanism that they're not telling you and you don't have to worry about it, that gives each digit a probability 0.1 of being a 0 or a 1 or a 2. So each time you look at the next digit, you don't know what it's going to be until you look at it. It's got about a 10% chance of occurring. And in the long run, as far as proportions go, that means that each digit will occur about 10% of the time in the long run. Okay? In the short run, they might occur a lot, but in the long run, the fact that the probability is 0.1 means it's a 10% chance, 10% of them, the proportion, would be the long run estimate. Again, this proportion is an estimate based on 200 repetitions of the true probability, which in this case is known to be 0.1, or at least assumed to be 0.1. Let's go ahead and do this part first. You can see part B is using software. We'll come back to that. Here's part A. We're going to look at our table of random digits. Here is the table. Over on the left, we've got the line number that we are looking at. You ignore the line numbers as far as the random digits go. They are just to help you start at different places, you know, and get consistent answers. We're going to start at line 101, which is the first one. If we started somewhere else, we'd get a different answer. We want to get the same answer that's consistent with the answer given in the book, and if a TA was grading this, everybody would hopefully get the same answer. So we are going to start at line 101. You can see the digits are in groups of 5 here, 5, 10, 15, 20, 25, 30, 35, 40 across each row. Altogether then, to get 200 digits, we need to look at 5 rows, since 40 times 5 is 200. Alright, so I'm going to go ahead and count the number of zeros in the first 5 rows here. That's a little bit boring, but so you could pause the video and count yourself. That's probably a good idea. See if you get the same answer as me. I will now proceed to count. Hopefully you can see my cursor there to keep track and make sure I don't make a mistake. So I'm going across the first row. There's the first 0, 1, 2, 3 in the first row. Then on to 4, 5, 6, 7, 8. On to the third row, 9, 10, 11, 12. How about that? 3 zeros in a row. That does happen sometimes. 13, 14, 15, 16, 17, 18, 19, 20, 21, and that's the last 0, and I know that is the correct answer. There are 21 zeros in the first 5 rows of 200 digits. What is that as a proportion or a percent? 21 divided by 200 would be the answer. That turns out to be 10.5%. Let's go ahead and type the answer here. Here's what my students should do, by the way. The proportion, if I can spell here, proportion of zeros in the first 200 digits is 21 divided by 200 That's 0.105. You can check that with the calculator, or 10.5%. Pretty close to what you would expect. Since the probability is 0.1 or 10%, you should expect an answer pretty close to 10%, and this is. Okay. By the way, you can have the spreadsheet calculate that for you as well. You can type an equal sign to make it do math. 21 divided by 200 is 0.105, or 10.5%. You can also convert this to a percent if you like as well by pressing that percent button. This is again Google Sheets. Excel works pretty similar. All right, so that's the first part. So that's one lesson about probability. The long-term proportion. Okay, this proportion is an estimate based on 200 repetitions of the true probability, which in this case is 0.1. If you'd picked a different line though to start on, you'd get a different answer possibly. Okay, though it should be still relatively close to 10%. You might want to try that on your own. Pause the video and look at say at line 106, for example. All right, let's go on to part B. Now use software assigned by your instructor. You will use, my students will use Excel or Google Sheets. I'm using Google Sheets, and the instructions are basically the same. We're going to be entering a formula, a function you might say, ran between 0, 9 in cell A1. That's going to cause the spreadsheet to pick a random digit between 0 and 9 at random. You're not going to know what it's going to be when you enter it. It's going to be one of those 10 digits. Then we're going to essentially copy and paste. Drag the contents down through cell A1000. We're going to get a sample of size 1000 here. Okay, that's the number of repetitions or trials. You will find 1000 random digits 0 through 9. Here's something important, a little tricky. Any attempt to copy these digits for sorting purposes will result in the digits changing. That's a built-in feature for spreadsheets, and it's a good thing in general because you want it to change to simulate other random samples. So that's something to be aware of, and to do something about it, you need to freeze the generated values, and essentially to do that you have to do a paste special as values. Okay, I'll show you what that is here in a second. Let's go ahead and do it now, in fact. Okay, so we're back to the spreadsheet here. Functions like ran between do need an equal sign right away as well. And in fact, I always try to emphasize by saying the function is not ran between, it's equals ran between, to emphasize that you gotta put an equal sign there before you can use a built-in function like this. Equals ran between, and I'm not sure why it's not showing up as, sometimes it shows you what the possibilities here are, and I'm not sure why it's not showing it here, but let's go ahead and just go with it anyway. Sometimes when you type things, it'll show you different functions that you can choose from. Anyway, this is what we want. Equals ran between. I'm about to hit enter here, and I will see one digit that's 0 through 9, one of those 10 digits. I don't know what it's going to be, but I know it's going to be one of those 10 digits. It's a 7, okay? If I copy and paste this function, this formula, into some other cell, I will get, say, A2, I would get another random digit in cell A2, and the original digit in cell A1 will probably change. Not necessarily, but probably. Let's see what happens. Copy, paste, it changed to an 8, and this one's a 4. Copy, paste again, I get another change. Now I get a 6, 7, 2. Copy, paste again, I get another change. So again, this is a built-in feature for spreadsheets, and it's a good thing. When you're trying to understand something from random samples, it's good in general for those numbers to change. Let's go ahead and do all 1000 here. This will take, I don't know, 30 seconds here. I'm copying and pasting by clicking and dragging the lower right corner. You may want to fast forward the video by another 30 seconds to the end here. I'm getting 1000 digits with ran between, each having a probability of 0.1 of occurring. And there I am. I'm at 1000. I guess I could have just tabbed on down to the bottom there instead. 1000 digits, 0 through 9. Of course, you're going to get repeats. Okay, and of course, you can get the same digit more than once in a row. That can happen in the short run. In the long run, the probability of each of these is 10%. About 10% of these should be zeros. About 10% should be ones. About 10% should be twos, etc. All right, so now I want to copy and paste this into column B with the paste special, so I freeze the values. I don't want to sort these as is because it technically changes the digits that are there, although it's really not a big deal, you might say, because it's just a new list of 100 digits. But I guess for 1,000 digits, but I guess for the purposes of the grader, okay, let's put it that way. For the purposes of the grader grading your homework, they want to see a column that is frozen so they can check that to see if you did it right. Okay, so I'm going to copy and paste this. And let's just go ahead and do it through the menu up here. Copy and paste, but paste special. In this case, paste values only. Before I do that though, you might want to pause the video and write these down, or at least write the first 10 of them down. You want to make sure that we really are getting these values again. 37662186. Okay, I'll try to remember that. 37662186. 37662186. Now let's do this paste special into column B. Column A is going to change. I'm pasting values only. Here we go. Ready? 1, 2, 3. Column A changed, but column B is the original column A. 37662186, blah, blah, blah. These are the same as the numbers all the way down through those 1,000 rows as column A was. So that's good that now I can sort these and they won't change as far as what the number of zeros, for example. And I can write down the answer, and the grader will confirm that you did it correctly. We can now go up to data and sort. I think in Excel the sorting is a little different. You'll have to look that up in your version of Excel. Sort by column B, A through Z. That's going to go in order from least to greatest. Here we go. And for some reason it changed where my typing of the part A was here. I think it probably put it down there. I don't know why it did that. I wanted to just do column B, but it somehow sorted column D as well. How many zeros are there? Should be about 10%. Now there's 1,000 digits overall. 10% of 1,000 is 100. Should be somewhere around 100 digits here that are zeros. And there are 91 of them. Okay? Not as close as you might hope you might say, but close enough that I believe there was no mistake. Okay? Anywhere between 80 and 120 is probably a conceivable answer, and different people are going to get different answers, by the way. So the answer for part B is going to be 91 out of 1,000, or 0.091, or 9.1%. Let's see if I put my answer to A down here somewhere. Yeah, there it is. Kind of silly. I thought I was just doing column B. Let's copy and paste that up there. So now the answer to B is going to be the proportion of zeros and the 1,000 digits generated is 91 divided by 1,000. That would be 0.091 or 9.1%. Enter that. And if we want to double check to make sure the grader is going to see what we do, go back down there. And we see that, yeah, the last zero is in row 91. There's 91 zeros there. And we started in row 1. So this will be the right answer, and the grader will see that. Okay? But again, different people are going to get different answers in general. That's part of the nature of randomness and probability. But in the long run, the proportion should be pretty close to 10%. And this is, reasonably close. Thanks for watching.